Welcome to Queues and Deques. A queue is a line where the first item to arrive is the first item to leave. We will build one two ways, with an array that wraps around called a circular buffer, and with a chain of link nodes. Then we meet the deque, a queue you can add to and remove from at both ends. Let's start with why queues matter. You meet them every day, anytime people or tasks have to wait their turn. A queue always serves the oldest waiting item first. By the end of this chapter, you can do 5 things. First, you can update the front and the rear correctly. You move each one forward without losing an element. Second, you can tell a full queue from an empty one. You can reason about this even when front is equal to rear. Third, you can reason about the core operations. In queue, dequeue, front, and rear. You can do this for both the array version and the linked version. Fourth, you can read the wraparound. You can trace rear +1 mod capacity by hand. Fifth, you can see a deque as a bigger queue. You push and pop at either end, not just at one. One idea runs this whole chapter: first in, first out. Whoever arrived first leaves first, and we do it cheaply, both in an array and in a chain of nodes. Picture the line at a coffee shop, or picture a print spooler feeding one shared printer. Both work the same way. The first person in line is served first. We call this rule first in, first out. New people always join the back. Nobody cuts ahead. Only the order of arrival decides the order of service. So a queue is first in, first out, which we write as FIFO. The first element added is the first element removed. This is the opposite of Chapter 6's stack, which serves the most recent arrival first. Let's build a queue the simple way. We use an array. Front is the next slot to read, and rear is the next slot to write. Count is how many values are live. Here we start with capacity 6, 4 values in, and count 4. Front is at index 0, and rear is at index 4, the first empty slot. Now we dequeue once. We read the value at front, then move front forward one step to index 1. Watch index 0. It still holds 10, but front has passed it, so it is now wasted. We can never reach it again. Dequeue a second time. Front moves to index 2. Now index 0 and index 1 are both wasted. The queue keeps shrinking from the left.